All right, let's start again. All right, so you got 4 goals for this section. The first one is to balance unbalanced equations. And you're going to use coefficients. Coefficients are big numbers to place in front of formulas to balance the number of atoms. And that's what this bottom section is. This bottom section is what you're going to be doing. So in other words, on your test, I may give you some unbalanced equations and you will balance them. That's goal 1. That's what you should be able to do. The second thing you should be able to do is if I give you a word equation, you should be able to write formulas, hence you must know your ions, and balance the equation. So in other words, if you'll flip through these notes to the next section, and it says, state type of reaction, write a chemical equation, then balance the equation. So all of these, what do you have to be able to do? Write formulas, write symbols, and then you'll end up with, after you write formulas and symbols, you'll end up with what you have here, in essence, and then you'll balance it. So this is like one more step you have to be able to do for these. The next thing you have to be able to do is determine the type of reaction. And I have listed for you these 6 types of reactions, and we're going to go over these today. So you will need to be able to tell me, what type of reaction is this? And so from any of these, you're going to be able to tell me, and that's what we're going to do. We're going to tell which type of reaction is it. And then the fourth thing you're going to have to do is basically the comprehensive of all of this is predict products for the following types of reactions. A simple combination or synthesis reaction, that's like an A plus B yields C. That's a combination reaction. You're going to have to, I will give you A plus B. You have to figure out what C is going to be. All of your single and double displacement reactions, which are these, you should be able to predict the products for. And all of your combustion reactions, and write balanced equations after predicting the products. So if you look at this last section on the back side, this is what we're talking about. So if I give you only reactants, you can predict the product and then write a balanced equation. Do you think you need to know your ions? If you don't know your ions, can you do this? No, you can't. That's why we've been doing nomenclature in lab forever. That's why we've pushed you to learn your ions. Okay? So, you've got to stretch yourself a little bit. Want to just kind of go over real quickly a little bit on ions and nomenclature for a minute. I've talked to numerous people in my office who have not done well on their nomenclature, and when I ask them, do they know your ions? Well, some of them. Well, some of them isn't enough. Then I'll say, well, when you are doing nomenclature, do you have your ion sheet out? Yes. Do you look every one of them up? Yes. There's the problem. You're not depending on this head. And that is a problem with, honestly, all of us nowadays. You all don't know phone numbers. Why not? You can look them up on your phone. Do you have to memorize anything anymore, really? No, you got a calculator to do your math. You got a phone to remember phone numbers. You don't have to remember anything. You don't have to remember directions. Siri, how do I get to da-da-da? You don't have to remember anything. Your brain is turning into mush. Use your brain. When you have nomenclature in front of you, you do everything you can do with a periodic table before you ever look for that ion sheet. Make your brain work. Make it work, guys, okay? Make it work. You've got to start doing that. I understand you guys, and I know I've got somebody who always says, well, this is just stupid. You got to quit giving excuses. You got to quit giving them the COVID excuse. Well, you know what? I understand COVID messed you all up to a certain extent because you had online tests. You didn't have to study. You cheated your way through high school, some of you. I'm not saying all of you, but I know for a fact that's how some of you did it. Guys, this is not high school. This is college. You got to buck up. I do not want people who are 30 years younger than me and younger to be able to not know any memorization when they get to be my age and older. You're going to be taking care of me. You're going to be making decisions for me. You're the people I'm going to be going to get help when I'm really old. If you can't remember anything, is that going to be helpful for you in the real world? And you say, well, I'll have my phone then. What if the electricity goes out? What if all the phone systems go out? Didn't AT&T go out the other day? What happens? You've got to use your brain. Please, God gave you this head. Use it. Please use it, okay? I know you don't like me fussing at you, but if I didn't, I feel like nobody tells you these things. I feel like your parents, some of them, have let you be on that stupid phone all the time and not made you work. And you've got to learn how to work, okay? So I really, really encourage you to start using your brain, okay? I'm not trying to fuss at your parents, but get off social media and use your brain, okay? All right, so here's what we're going to do. The first thing I'm going to do is practice balancing equations. We're not going to worry about anything else except balancing these equations to start with, okay? That's what we're going to work on. So grab a pencil. You cannot balance equations with a pen. Why is that? Because it's so easy to make mistakes and you want to be able to erase it and move on again. So grab a pencil to balance equations with, if you have one. Now, if you've had this in high school, a lot of you probably had a teacher that made you write everything down. And it was a pain in the tail. And you don't need to do that, okay? So you do not have to do that. It's a waste of time, and it honestly is more confusing a lot of times. I'm going to give you some hints, okay? First hint on balancing equations. Well, first of all, maybe I should refresh your memory for a minute. Reactants, let me go to the top here with the pen. Reactants yield products. Did everybody remember that from something else maybe? We've talked about this before, I believe. So who's on the left? Reactants. Who's on the right? Products. That you've got to know, and the arrow means yields, okay? That you have to know, and the arrow means yields. If you see little symbols, subscripts, like an S, an L, a G, an AQ, those will be symbols. Can't spell symbols, can I? Symbols after formula. What do these mean? S means what? Solid. Good job. Liquid. So you all remember these. Gas and aqueous, or aqueous, however you want to say it. We always have AQ after all of our acids. So these are things that you've seen, you've heard of, you know. So I just wanted to point that out so you don't get confused if you see those. All right? So now then, on our balancing, so some balancing hints. Some balancing hints. Do not write coefficient 1. Do not write coefficient 1. When there's nothing in front, you know it's 1. You don't write 1, okay? Do not write coefficient 1. It's not like I'm going to hand grade these, so I'm not going to count it wrong if you put 1. I'm just telling you you don't need to put 1. All coefficients should be in reduced state. So all coefficients should be in reduced state. Let me explain what I mean by that. Let's say down here I ended up balancing this and it was 2, 4, 2, 4. Then what would I do? 1, 2, 1, 2. Does that make sense? So you put them in their reduced state. Put them in their reduced state. For your final answer, they should be in the reduced state. Okay? All right. And if the same polyatomic ion on each side, keep it as a unit. If the same polyatomic ion on each side, keep it as a unit. Don't break it down. It makes it so hard when you break it down. Do not break it down. Keep it as a unit. That's one of the reasons you have to know your polyatomic ions. Okay? There will be some more hints. I'm going to start here. I'm going to add some more hints later. So let's go down to balance the following. What's the hint you're going to use to start with? If the same polyatomic ion on each side, do you keep it together? Yes. Do we have that? Yes. Who is this? Nitrate. So keep this as nitrate. And sometimes I do that just so I can see it's nitrate. Is there another one? Who's the other one? Chromate. So keep chromate. Keep chromate. Now, I don't write everything down. This is not rocket science, and even if it were, you could do it. It's not hard. Count. Don't write it down, just think. Look, how many PBs? 1. How many PBs? 1. So in our brain, check. How many nitrates? 2. How many nitrates? 1. So what do we put in front? 2. Okay? Now, how many Ks? 2. How many Ks? 2. Do you see? 2. How many chromates? 1. How many chromates? 1. Now let's do that again. How many PBs? 1. How many PBs? 1. How many nitrates? Nitrates. Potassiums. Potassiums. Chromates. Chromates. Check. Does that make sense? You don't have to write anything down. That's what you do. It's a game. Go back and forth, playing the game till it balances. Okay? All right, let's look at the next one. Now the next one, does it have the same polyatomic ion on each side? No, it doesn't. So everything has to be broken down. Again, don't freak. Let's just look. 1 Mn, 1 Mn. Now let me also warn you. You cannot, when you're doing these, you have to pay attention where the arrow is. Sometimes in our brain and our eyes, we tend to want to think the arrow's the same place. See how like these two have the arrow on the page the same place, and this one the arrow's there. It's like you have to look for the arrow. If it means highlight the arrow or something, you got to pay attention to the arrow, because it would have been easy to start putting this together and these separate. So put the arrow where it is. So 1 Mn, 1 Mn. Yes or no?
Yes.
Okay. How many O's? How many O's on this side? Only 1. So what do we want to put in front of this? 2. All right. How many H? How many H's? 4. What do we put in front? 4. How many Cl's? 4. How many Cl's on the right side? 4. Double check. How many Mn's? 1. Oxygens? 2, 2. Hydrogens? 4, 4. Chlorine? 4. 2 plus 2 is 4. Check. Yes? All right. This one is the same polyatomic ion on each side. No, it's not. So we have to break it down. How many sodiums? 2. How many sodiums on this side? 2. How many carbons on the left? Carbons on the right? 1. Oxygens on the left. Now be careful. 5. Good job. Do you see 3 plus these 2? That's 5. Oxygen's on the right. 2 plus those 3 is 5. Sulfur's on the left. 2. Sulfur's on the right. 2. Cha-ching, what is it? It's balanced. So you put, it's balanced. And you can always double check. It's always a good idea to do them twice to make sure. Double check, but this one is balanced. All right, you do the next one. You do the next one. All right, what do you have? On the left, how many silvers do we have? 2. So what do we put here? 2. All right, how many sulfurs on the left? Sulfurs on the right? Hydrogen's on the left? Hydrogen on the right? 2. Check. All right, on this one, do you have the same polyatomic ion on each side? I like your... He's doing this. That's exactly how I feel. Sort of. You sort of do. You don't exactly, but you sort of do. And his sort of is what helps. We don't have the bicarbonate ion on each side. But do we have carbonate on each side? So if you will break this as carbonate, it will help you. You don't have to, but it helps. If you break that as carbonate, it will help. Try balancing it, leaving that as carbonate. See if you can do it. All right, so you've got 1 mg on the left, 1 mg on the right. How many H's do you have right here? 2 plus 1 is 3. Over on the right-hand side, you have 2. Now, I have a suggestion when you have this situation. I'm going to write this down in a minute. Does that seem easy at this moment? Some of you say yes, I say no. Because that's an odd and an even. Skip it for a minute. You don't have to do these in order. Skip it for a minute. Carbonates, how many? 2 carbonates here. So is that an easy fix? Okay. Now, we're skipping hydrogen for a minute. Chlorine. How many chlorines do you have on the left? 1. How many do you have here? So let's put a 2 here and get those chlorines balanced. Now let's go back. 1 mg, 1 mg. How many hydrogens here? 2 plus these 2 is how many? 4. How many hydrogens? Did it just do it itself? It balanced itself for you. You didn't have to worry about it. How many carbonates? 2. How many carbonates? 2. How many chlorines? 2. How many chlorines? 2. Do you see? So let's write some more hints down up here. I'll come down here with my hints now. Number 4, 4th hint. If one element seems difficult to balance, skip it and come back. If one element seems difficult to balance, skip it and come back. You do not have to do these in order. The fifth hint, if water on one side and hydroxide, OH, on other, write water as HOH. If water on one side and hydroxide, OH, on other, write water as HOH. In achieve, change it back to H2O. You cannot write water as HOH in achieve. I'm telling you to help you balance it. To help you balance it. If water is on one side and hydroxide's on the other, then write the water as HOH. But then in achieve, change it back to H2O before you enter it into achieve, because it won't accept HOH, okay? And there's probably going to be one more hint, but let's keep going. It's not really relative until you see how practical it is. We got the hints? If water on one side and hydroxide on other, write water as HOH. In achieve, change it back to H2O. All right. I'm going to let you try to balance these two by yourself. You try these. Have we got it? Are we having difficulty on one of them? Both of them or just one? Just one? Okay, let's do 6 then. All right. So how many C's? 3. So what did you put here? 3. All right, so C3, C3. H, how many? 8. So what do we have here? 4. So that's 8. And then oxygen, we get to put whatever we need here. So let's see. 3 times 2 is 6 plus 4 is how many? 10. So how many do we need here? 5. Good job. Everybody get that one. Okay? All right. Now, the next one is where you're going to need the other hint. So you say 3 C's. So what'd you put here? 3. H8. What'd you put here? 4. And then you saw 6, 10. But then we had this 2 and a 1. So we had this even scenario and this odd scenario. You follow me? This is an odd number of total oxygens. This is an even, and there was no way you could ever get those to balance unless you made them both even. So here's your last hint. I'm going to put the last hint on this page because it's relative to this page. So, if you can't get everything to balance, double every coefficient that you have written, including 1. If you can't get everything to balance, double every coefficient that you have written, including 1. So do that right now. So what does that mean, changing this to? The first one. 2. That's what I mean when I say the one you've called 1. So this becomes 2. This becomes what? 6. And this becomes 8. Let's see if that doesn't solve your problem. Have you got it? So what do you need to put in front of this one? 9. You put a 9. Why do you put a 9 here? Because look what happened. You had 6 carbons, 16 hydrogens, 16 hydrogens. 6 times 2 is what? 12 plus 8 is 20. Take away 2, because those 2, how many do you need this total to be? 18. So you put a 9 in front. Does that make sense? That is a useful hint. Now, let's just say you can't get something to balance, so you double everything. Then you come back and you look at it and you say, wait a minute, that could have been reduced. What do? Reduce it, but you cannot reduce this one. You can't reduce this one. Something that I did not say, and I need to add it, this should have been the first thing I said, so let me go back where it talks about coefficients. Right here is the place to put it. All coefficients must be whole numbers. They must be whole numbers. In other words, you could not have had 4.5. All coefficients must be whole numbers. All right, so you've got practicing to do on balancing. I would encourage you to redo this page on your own without having it done for you, just to confirm you can do it. Where the trouble is going to be is if you don't know your ions on these. So here's what we're going to do first. I'm going to deal with stating types of reactions at the end. Right now, I want to focus on just simply writing equations and balancing, okay? So what I want you to do right now is just this section. I want you to go through there and I want you to start writing formulas. Do not worry about balancing anything right now. I want you writing formulas. Now I'm going to show you what I think you need to do for this, okay? Let me just show you. Barium is an element. You simply write Ba plus. Now what's lithium's charge? +1. What's chloride's charge? -1. So that formula is LiCl yields barium's charge. What is it? +2. Chloride's charge? -1. So that formula is BaCl2 plus Li. Do you see what I'm doing here? What am I putting on the names? The charges. I'm putting the charges on the names. That's okay. Do that. Don't put charges down here, but put them in the name. So now that's unbalanced. Move to the next one. Keep doing that. Keep doing that. Off your phones, guys. Come on. Get to work. You're going to be gone next week. Come on. Be here today, right now. Practice these. right, I'm going to go ahead and start these now that you've gotten a good head start on me. All right, that's what you should have. Notice what I put in the top right corner of my little paper here. What is that all about? Who are those? Diatomic molecules, which means when they are alone, how must they be written? H2O2, F2, Br2, I2, N2, Cl2. How many of you did not do that on those last three problems? A couple of you want to admit it? Good job. Yeah, and that's why I did that. Make a note to yourself. Don't forget. 2. Okay? Don't forget 2 for those elements. Make a note to yourself so that you don't forget that. That'll totally mess you up on a test if you forget those. All right, any other questions on what I've done here? Did everybody get these? These are all unbalanced. Got it? Oh, sorry.
For the Mercurus one, would it be HgCl2?
No, because Mercurus is Hg2. Mercuric is Hg. It's opposite of what you think. Mercury 1 is Hg2, Mercury 2 is Hg. It's the goofy. You got to just think opposite, okay? And you do not reduce this. That's what I thought you were going to ask. You do not reduce this. Why do you not reduce it? It's an ionic compound and you do not reduce that. Because Hg2 is what Mercurus is, you have to leave both 2's. Okay? Other questions on any of these? Yes, no? Okay. All right, so let's balance then. Start. Balance them. I wanted you to double check to make sure you had these right before you balance, but now balance. All right, your first two I did for you. Double check yourself. So you have 1 Ba, 2 LiCl, 1 BaCl2, and 2 Li. That one was easy. The next one, NiBr2 plus K2O yields NiO plus 2 KBr. Everybody get that one? That was easy. Now the next one's a little bit difficult though, at the beginning. How many of you said 2Hg and you immediately put a 2 here? Good. And then you said 2 Cls and you looked here and you said, uh-oh. So what do? What'd you do? Double it. Well, now, let me ask you a question. In doubling it, it won't work immediately because you'd still end up with 4 here and 6 there. That's still not going to balance. A 3 and a 2, the only way you're going to get that to balance is to make a total of how many? 6. So what are you going to have to put in front of this? A 3. So you're going to have to put a 3 here that made 6 mercuries, 6 mercuries, 6 chlorines. What do you put here? 2 and then 2. Okay? So oftentimes, and if you want to write that down as a hint, you may do that. Oftentimes, when you have a 2 and a 3, it's going to have to be a total of 6. And this happens a lot. That happens a lot. The more you practice, you're going to get this. This is your first day, and you need to practice these on your own. All right, keep going. You're going to find another scenario like that in a minute. Very fast minute. Not a minute, a second. And it's not a 2 and a 3, it's a 2 and a what? A 2 and a 5. What do you need to do to make that 2 and 5 balance out? Well, you're going to have to make it 10. You're going to have to make it 10. Make it 10 oxygens on each side. Sometimes you just have to play with it. And there's nothing wrong with sitting there playing around and trying to figure out your numbers. You got a good brain, figure out what would be the total I'd have to be here. So keep going, finish the rest of these. All right, what do you have here in front of N2? You put a 2 here, okay? So that made 4 nitrogens. What'd you put here? 2, 4 nitrogens. How many oxygens? 10, so what's here? 5, good. And you had to do that based upon your who? Who made you, how did you know to do that? Oxygen. It was your oxygen that messed you up. And so then you had to do that. Oxygen oftentimes messes you up. Okay? All right, on the next one, what did you put in front of aluminum? 4. Keep going. 3 and 2. Good. All right. What do you have on this? Come on. 2. 15. Man, those are big numbers. You sure? So 12. 12, 12, 12, 30, 6 plus 24 is 30. Can they be Big numbers if needed, yes, and those aren't huge numbers. Can that be reduced? No, that cannot be reduced. Does that make sense? Okay, was this one that you used the hint double everything when you couldn't get it? Good, good, okay. All right, now, let's go back. What are the goals? The goals were that you could balance unbalanced equations. Have we done that? I'm not saying you can do it by yourself yet, but some of you could. So we've balanced unbalanced equations. Write balanced equations from word equations. Yes, I will learn my ions, Miss Brooks, so that I can do this. That's what this was. And balance them. And then number 3 is determine the type of reaction. So we have 6 different types of reactions. Now that seems like an awful lot to be able to identify, but really it's not. Not hard at all. So I'm going to go through all of these. Combination and synthesis is combining. That's what that means. Combining, making one product. That's the key. Look, one product. That's the key for combination or synthesis. Okay? This is like a good marriage. That's what that is. That's a good marriage. Man, wife, married, live forever ever after happily, right? That's the marriage. That's the good marriage. All right, decomposition. Notice the difference in combination and decomposition. What do you have on decomposition? You have the divorce. That's exactly right. You've got one reactant. You have one reactant. So you on combination and synthesis, you have one product. On decomposition, you have what? One reactant. Are these opposite? Look, are they opposite of each other? Yeah. Yeah, they're opposite of each other. They're opposite of each other. Then we have single displacement and double displacement. I'm going to skip those for just a minute. I want to go down here to combustion of a hydrocarbon and incomplete combustion of a hydrocarbon. First of all, what is a hydrocarbon? Now, folks, keep it simple. What is a hydrocarbon? Hydrogen and carbon. Hydrogen and carbon and sometimes oxygen. Hydrocarbons are what you run your car on. Gasoline is a hydrocarbon. Hydrocarbons are what you have if you have a gas furnace. Hydrocarbons are what you have when you have a propane tank and a gas grill, a butane lighter. You with me? A butane torch. All of those, acetylene torches for welding, all of those are hydrocarbons. Are we burning hydrocarbons a lot? Do we burn hydrocarbons a lot? Yes. Is that what combustion is? Yes, combustion is burning. So what we're dealing with here is burning a compound that contains carbon and hydrogen. If it completely combust, you will always get carbon dioxide and water. Complete combustion always produces carbon dioxide and water. Always. No choices. No choices on what it produces. It always produces that. If it does not burn to completion, incomplete combustion will produce what? Carbon monoxide and water. What should you have in your home if you have a gas furnace or any gas appliances? A carbon monoxide detector. Why do you have a carbon monoxide detector? Because what does carbon monoxide do? Kill you. Kill you. It can kill you. How does it work? It works by putting you to sleep, basically. It works because it bonds to your hemoglobin in place of oxygen. It basically suffocates you slowly, and you sleep. Usually you'll have a really, really bad headache. One of my students in the past before I retired, she was my past leader. She did sessions with my students in 109. She was with me for like 3 years. And she literally, when she was a little girl, she and her younger brother, they woke up one night and their heads were killing them. The dog was like yelping like crazy. And it ended up that their furnace, it was not burning properly, and they were experiencing carbon monoxide poisoning. And the dog is what woke them up from its yelping, and they were able to get out and get fresh air, and then they got their furnace fixed. But that, it can happen. It's a very real thing. And so anytime you have a gas furnace, you have a carbon monoxide detector. You also should not ever use a buddy heater in a garage that's closed in. You should not ever run your car in the garage. You should never ever leave your child asleep in the car and it running in an enclosed place, or anywhere for that matter. Pick your kid up. Even if he wakes up, you take him in the house. You don't leave him asleep in the car running. Okay? Those are all things that you don't do because of carbon monoxide poisoning, and that's why. So you're going to have to know, if I tell you, and you'll have to pay attention, if I say to you it is complete combustion, then what does that mean? Your products will be CO2 and water. If I tell you it's incomplete combustion, then you'll know it's carbon monoxide and water. So let me just show you something. For example, over here, I don't tell you which one it is. Here, I don't tell you which one it is. Here, I don't tell you which one it is. If I don't tell you, then you make the assumption it's what? What's the good one? Complete. Complete. You make the assumption it's complete combustion. Now, some of you are tilting your head saying, well, how do you even know that's combustion? How do I know this and this and this are combustion? What is this? Carbon with hydrogen, adding oxygen. What is that telling you this reaction is? Combustion. Same thing here. Is this carbon plus hydrogen? Or carbon hydrogen compound plus oxygen? What's the product's going to be? Come on. CO2 and water. CO2 and water. Same thing here. Combustion. Okay? Now, just so that you'll know, this one's kind of funny. This is sugar. This is sugar. This is sucrose. You eat it. Sugar. This is what we like to eat. This exact reaction is what goes on in your body. When you eat sugar, is it reacting and burning? What do we call it? Do we say we're burning calories? That's in essence. Are we shooting off flames from our nostrils? No. But are we mixing our food with oxygen in a metabolic reaction? Yes. Do we produce carbon dioxide? Yes. And water? You get the point here, okay? You with me? Isn't that wild? You do these combustion reactions in you. You're a big furnace. And what's one of the products of that? Heat. Isn't that wild when you think about it? You are a furnace. That's what your body is. You're burning carbohydrates, which are hydrocarbons. Does that make sense? To produce carbon dioxide and water. And as long as you have enough oxygen, which we do, then we are complete combustion. Okay, so it's kind of cool when you think about you, and you are doing the combustion of a hydrocarbon. All right, so combustion of a hydrocarbon, incomplete combustion of a hydrocarbon. Folks, don't make that hard. That's the easiest ones on here, because you're just simply looking for a hydrocarbon mixing with oxygen. That's what you're looking for. And then you'll know the products depending upon which one it is. Combination, you're going to be able to identify that one easily because it's only going to have what? One product. Decomposition, you can identify easily because it's only going to have one reactant. Okay, so let's look. Were any of these on the front page, any of those four we've talked about? You're right, Lucas, none of them. These 5 on this front page are none of those 4. So we're still missing some. which we've got some to talk about. Now flip the page over. Tell me about these two at the top. What are they? Combustion. So label them. Label them. Combustion and combustion. Those two are combustion. Okay? Now, keep going on this page and see if you can identify any of these that we've talked about. Here, I'll give you numbers here. We'll just keep numbering. 8, 9, 10. Can you identify any of these that we've talked about? Any of those 4? Tell me which one you can identify. Which number? 11. Tell me what 11 is. Combination. Combination or synthesis. You can use either name. Combination or synthesis. Good. How did you know? One product. All right. Anything else? 12 is what? Same thing? Okay. All right. What's 13, Lucas? Combustion. Good job. So you, again, that's part of your goals, is you need to be able to identify the types of reactions. That's what you need to be able to do. Identify types of reactions. And that's going to help you when you get ready to predict products. But we actually are going to do predicting products when we come back. We're going to do this when we come back more than today. We got 2 more to talk about, and this is something I used to do a long time ago, and then I kind of quit doing it, but I'm going to do it today just because it's fun, and I'll do it today. So Alfredo is going to help me, and he agreed. He's scared now. McKinley is going to help me. So come up. These people are in my lab, so they already knew that they were going to have to help me. Adrian, in a minute, I'm going to have you help me, but I forgot to tell you. Okay. All right, so we have 2 different types of reactions that we haven't talked about. Single displacement and double displacement. So first thing we're going to do, McKinley, can you scoot back for me, please? All right. First thing we're going to do, we're going to talk about we're going to start at the top. Letter A, combination. Combination is A plus B, and then we go through the arrow and we become married. Okay?
No.
All right, does that make sense? That one's easy. Decomposition is we start off as married and then get out of here, dude. And then we separate. Okay? That makes sense? All right, so those are easy. All right, now then, we have the single displacement. Now we have the single displacement. So what are we? Well, are we a compound? We're a compound. Here, let's get in the front here where everybody can see us here. We're hiding behind the thing there. All right, so we have this married compound. Now, I'm a metal. That means he's a non-metal, and that means she is a, come on, metal, non-metal, come on, metal, metal. You with me? Metal, non-metal plus a metal. Okay? So, the single displacement reaction is quite kinky because you have this compound and then this more active element kicks out the less active element. And metals are always listed first, yes? So, did we have a more active element kicking out a less active element? Do you get the humor of all this?
Yeah.
Now, would you really like to know the real humor of all this? This is my daughter.
Actually,
No joke.
yes.
So, we just talked about this. I told her last night, I said, do you want to do this with me? I said, it's going to be hilarious because, you got to get all the puns here. The less active old hag and her daughter replacing her. You got to get the humor of this. It's hilarious. I never had, I have had a daughter in class before, but I told her, I said, will you do this with me? I said, it'll be funny. And we have purposely not told anybody that my daughter was in this class for multiple reasons, but I think the multiple reasons are gone now, so it's okay to share that this is my daughter. So, anyway. So, funny thing, and Alfredo was clueless to the whole situation. So, but I asked Alfredo in the lab yesterday, I said, will you play along? He said, yeah, I'll do it. So Alfredo's a lucky guy. All right, hold on, we're not done with you. We're not done. All right, Adrian, come on down. All right, so what reaction did we just do? You got to get the chemistry here. Which one was this? Single displacement. Okay, so that one we call the Great American Affair. This one is, what kind of reaction are we going to be now? Double yeah, you did it! Swingers! Woo! Good job, buddy. That's exactly what I call it. This is the Swingers Club. Okay? Do not try this at home. Okay? So we have the compound with the metal that's with the non-metal, or the cation with the anion, and we have the compound that's the cation with the anion. We go into the reaction chamber and we switch. And so now we have a new compound and a new compound. Does that make sense? So do not try this at home. Okay? Now, let me talk about something for a minute. Did the metal switch with a metal?
Yes.
We do not have this. Okay? No chemistry does this. Okay? That won't happen. That will not happen in chemistry. Okay? So it's always going to be, make sure you realize it's always, and I'm saying this, and I know some of you are thinking I'm joking. I'm dead serious in the sense that when you switch those, you have to keep the cation has to be first, the anion, the cation, the anion. Okay? You can't put two, you're not going to get an ionic compound bonding or reacting with an ionic compound that then produces a molecular compound. You with me? It's going to be an ionic compound reacting with an ionic compound, switch, they still stay ionic. Okay? Does that make sense? Thank you guys very much. Okay. All right. All right, so now then, let's look at these. Let's look at these on this first page. Can you tell me, number one, what type is this? It's double displacement. Look at it again. Does lead switch with potassium? Look at it. Lead is with nitrate, but on this side, who's with nitrate? Potassium is with nitrate. Do you see what's happening? So is this a double displacement? Don't call it swingers, okay? Call it double displacement. Call it what it really is, okay? So this is a double displacement. That is a double displacement reaction. All right? This one is not one we've learned, okay? This is not one you can identify. This one is also not one you can identify. It's not one that we've really done. What's number 4? Single displacement. Do you see that? So who kicked who out? Hydrogen kicked out silver. Hydrogen kicked out silver. Hydrogen kicked out silver. Do you see how hydrogen was the single and hydrogen kicked out silver? Does that make sense? So this is a single displacement. Single displacement. This number 5 is basically a double displacement, but it's a little bit off, okay? So we can just leave it. I wouldn't ask you one that's off, okay? It is basically a double displacement though. All right, so flip now. You label these. You've just got 3 to label. Label those 3. All right, what's number 8? Single displacement. Who is the more active element? Barium. Do you see that? Does barium kick lithium out? Does that make sense? Okay. All right, what's the next, number 9?
Also single displacement?
Nope. Look, honey, you got 2 compounds. Okay? When you have 2 compounds, see if they switch. And so this one is double displacement. This one is double displacement. All right. And number 10, single displacement. Who's the more active? Who? Aluminum. Good. All right, so this one is single displacement. Now, before you leave, hold on a minute. I want to do one more thing right here at the bottom, just to kind of make you realize what's coming up, and you can even, some of you could finish these, honestly. Your brain's fresh right now, so it might be a good time to do it. When we start to predict products, you need to know what type of reaction it is. What type of reaction is this going to be? Single displacement. Do you see that? Who is fluorine going to kick out? Now be careful. I've only done ones up, and up here I did metal replace metal. Does that mean only metals can replace metals? No. Can non-metals replace non-metals? Yes. I just did it as a metal replacing a metal. It doesn't matter. The bottom line is the same type has to replace the same type. What is this? Well, tell me what type of reaction. Single displacement. This is a single displacement. If you know the answer, go ahead and write the words. What is this one going to be? Double. This one is a double displacement. This one is a double displacement. Okay? All right, guys, be safe, make good choices during spring break, and everybody come back, okay? I will see you in a week.
What do you mean you taught me something? I'm gonna do the Twitter stuff.
You got no. Do not do any chemistry or physics during spring break. I said make good choices.
Oh, stay away from that for let me know.
Are you going to Florida? Are you going to Florida?
I went to cruise this summer. I saw that every